Good morning, everyone. Very good morning, Shreya. Good morning, everybody. All right. So, sphere we have started, right? We have done one concept of equation that include two kinds of equation: general equation and the central form. We'll be working with the we'll be working with the general form of the equation of the sphere, and after that, we also did equation of a sphere passing through 4 points, right? Through the question, actually, it was much easy. We do not need to consider this determinant in the article. है ना? When it becomes easy to solve for those unknowns, then we can do that as well, right? Very good morning, Anjali. I think we ended our discussion with a question here. Okay, diametrical form of equation we were talking. Yes. So in this form, beta, if this was the theorem also we did. So basically, the angle in the semicircle is 90 degree that we have to use. Instead of 4 points on the sphere, if I know only 2 points, but those 2 points should not be any 2 points, they should be points on the points in the diametrically opposite points are given, then those 2 points are enough to get me the equation of sphere, right? Now, how this is going to help us, you see, I have taken a random point xyz as a on the uh, sphere, right, which is x comma y comma z. So basically, I'll find the equation involving x, y, z. Look at line AP. Can I find direction ratio of AP? Because P is also known and A is also known. So we can find direction ratio of AP, right? Direction ratio of AP is x minus x1 comma y minus y1 comma z minus z1, right? And direction ratio of AQ is y minus x2, y minus y2, and z minus z2. They are what? They are perpendicular, right? So since AP is perpendicular to AQ, since AP is perpendicular to AQ, is perpendicular to AQ, x minus x1 times a1 a2, a1 a2 plus b1 b2 plus c1 c2 is equals to 0. So y minus y1, y minus y2, and this is your equation. Will not open it, right? This is the equation with 2 points is equals to 0. Equation in diametric form. Next, this is a required equation of sphere. Try this question. The plane ABC, whose equation is x by a plus y by b plus z by c is equals to 1. Beta, this question, I told you, na, you have to write some of the notes of the question. Means if you see something, some result in a question, then you write it down. This complete question is a result. First, you prove this question, and then we'll remember the result of this statement as well. So the plane ABC, whose equation is this, meets the x's OX, OY, OZ in A, B, C respectively. Find equation of sphere OABC. There are 4 points given on the sphere. Origin ABC. Find out a sphere. Quick. Basically, in the equation of sphere, you use the fact that 0, 0, 0 satisfies it. Capital, this is O. Then capital A, which is obviously A00, 0, right? On the x-axis, it is written. These are the intercepts. B is 0, B0, and C is 0, 0, C. Okay. Try. Tell me what is the equation of sphere. Yes, that's the equation. Everybody got it? So, beta, we have the equation of sphere, x square x square plus y square plus z square plus 2ux plus 2vy plus 2wz. I'm already using the first fact because 0, 0, 0 means d is equals to 0. So I'm not writing d. See, first has been used because this implies d is equals to 0. Okay, so that's the equation. Now, if a also lies here, so what is it? If, let me, if sphere 1 contain A, then A square plus 2A UA is equals to 0. which means a plus 2u is equals to 0. I cannot take a as 0. Why? Because if either a is equals to 0 or a is equals to minus 2u, so it implies u is minus a by 2. It's the plane. Why we can't take a as 0? One reason is the intercept, right? It is in the denominator, it cannot be 0. The other also reason is that if all of them will be 0, then it will not no longer be a plane, right? So I need a non-zero values. Also, equation cannot have 0 in the denominator. That was in the equation of this straight line where the denominators was representing direction ratios. So I can have zeros in the denominators there, not here. Okay, so A, B, C, none of them can be 0. All right, moving ahead. Similarly, you can find V. Similarly, V is minus B by 2 and W is minus C by 2. Now, if you back substitute these values in equation 1, so equation 1 becomes, and beta, this equation of sphere you need to memorize as well. है ना? So, if I substitute this, it will be x square plus y square plus z square minus ax minus by minus cz is equals to 0. All right, and that is your answer. So always remember that if you have a plane passing through OABC, where you know O is the origin, ABC are on the x, y, z respectively, with ABC as the intercepts, small ABC as the intercepts. So then this will be your equation of sphere. Okay, it's not like it will not be very lengthy to prove this in a question as well, but sometimes the question is so complex that at least we can save this much of space, you know, by memorizing this. Okay, this is important. Let's do the another question. Question number 2. Show that the equation of the sphere through 3 points. Show that equation of the sphere through 3 points this. Now, see, the uniqueness is still there. If I have to find equation of sphere only through these 3 points, then it is not unique. But the fourth point is replaced by another condition. Having its center on the plane, this is this. Okay, so forget about this extra condition right now. How do we imply these three? These three condition will give me the three values of u, v, w, and d. Okay, so let's start. Let equation of let let equation of sphere be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equals to 0. Okay, so these equations can at least help us to find few variables here. Let's try. So if given points lie on sphere 1. Then 9 plus 4 plus 6u plus 4w plus d is equals to 0, which implies d has nothing in common. Okay, so 6u plus 4w plus d is equals to minus 13. That's the first equation from the first point. Next, minus 1. So 1 plus 1 plus 1, 3. Minus 2u plus 2v plus 2w plus d is equals to 0. It implies 2u minus 2v minus 2w plus d is equals to minus 3. I can add these two to eliminate d, but let's involve the third point also. And the last one is 25, 4, 29, 16. Okay, 5. So 45 plus 4u minus 10v plus 8w plus d is equals to 0. 4u minus 10v plus 8w plus d is equals to minus 45. That's the third equation. All right. We have to solve it. There is no other alternative. So 3 equations, 4 variables. So I can eliminate 3 variables. One variable will be there. So let us find everything in terms of u. Because one variable will be there. So let us choose in the initial that I'll keep u. So here let's eliminate d first. So what will be the value of d? Let's find out d from 3. So from 3, d is equals to 2u minus 2v minus 2w minus 3. Use it in 2 and 3. 2 and 4. Using it in 2. It will be 6u plus 4w plus 2u minus 2v minus 2w minus 3 is equals to minus 13. So this will be 8 plus minus 2v plus 2w is equals to 3 minus 10, 3 minus 13 minus 10. I can take 2 common. So 4u minus v plus w is equals to minus 5. Here we have fifth, sixth. Now use it in using equation 5 in 4. If I use it in 4, I'll get 4u minus 10v plus 8w plus d again. So plus 2u minus 2v minus 2w minus 3 is equals to minus 45. 6u minus 12v plus 6w is equals to minus 42. 2 minus 2v plus w is equals to minus 7. Now from 6 and 7, D is already eliminated. You see we have only 3 variables left now. So let's find out now W. Let's eliminate W now. So from D has been eliminated. Just a second. Let us take this as 6th and subtract 6 minus 7. 6 minus 7. 7U is cancelled. Plus W is equals to 7 minus 10 minus 3. So it implies W is minus 3 minus 7U. That is the first value that we got in terms of U. W we get in terms of U. Now V in terms of U can be obtained from equation 7. So let us say it from equation 7, U minus 2V minus 3 minus 7U is equals to minus 7. So let's find out V from here. Minus 3 minus 6U and 7 minus 3 plus 4 is equals to 2V. So V is equals to 2 minus 3U. That is the V. What else? D. So D we can get from here, from equation 5. What is D? D is 2 times U minus 2 times V. So minus 4 plus 6U minus 2 times W plus 6 plus 14U minus 3. U minus 1. Everything I have in terms of U. Alright. Now we want one more condition to get the values of U. If I get value of U, then I get value of D also, V also, and W also. Chalo. So having its center on the plane. Now this is interesting. How will I use it in my equation? Means how will I give it a mathematical expression? It says that sphere, the center of the sphere. What is the center of the sphere? Center of this sphere is minus U, comma minus V, comma minus W. Right? I hope you remember. Center of sphere 1 is minus U, comma minus V, comma minus W. Then the center is on this plane. That means that point is satisfying this equation, right? Which lie on given plane. The center of this is this, which lie on 2x plus 3y plus 4z is equals to 6. It implies minus 2u minus 3v minus 4w is equals to 6. Right? Substitute the value of V and W from here. It implies minus 2u minus 3. What is the value of V? V is 2 minus 3u minus 4. W is minus 3 minus 7u. This is from 8 and 9 is equals to 6 from equation 8 and 9, and you get all the values here. Minus 2u plus 9u plus 28u 35u. Okay, then minus 6 plus 12 minus 6 cancels. So u is 0. U is 0. All right. If u is 0, it implies from equation, let's start v, from equation 9. From equation 9, v is 2, 2 minus 3 times u. Yeah, just a second. So v is equals to 2. And from equation 10, what is 10? 10 is giving me, okay, 10 is giving me d. D is 22 times 0 minus 1, so it is minus 1. And equation, where's w? Equation 8 gives w is equals to minus 3 minus 7 times u, so it is minus 3. You have all the values, therefore equation of sphere is x square plus y square plus z square plus 2ux, u is 0, plus 2vx w z minus 1 is equals to 0. That's your answer. Acha. So beta, the answer for this is right here. This is the central form, right? Where the center is very clear. H comma k comma l means in from the equation I can find out. Here also from the equation we can find out, but I need to give this general form, this central form, so that it can be seen. So when I completed the square, it was the form which I was getting. So what is the center? Minus u, minus v, and minus w. So this was a good question. Let's try next question number 3. See. A plane passes through a fixed point, PQR, and cuts the axis in ABC. Show that the locus of the center of the sphere, OABC, is this. There is a plane which passes through a fixed point. Okay, so what is unique about this plane is only that it passes through PQR point. Nothing else. This ABC is changing, right? The plane is only passing through a fixed point P, which is PQR. So let first of all this P be small PQR, and and A is A comma 0 comma 0. B is, so there are 2 things you have to note here. Number one, first I have taken this small a, small b, small c by myself. That is not given in the question, so I need to eliminate that. Right? Number one. Number two, that because they are changing, so that is responsible to give me the locus. right? Plane is moving. See, you can also imagine that through a point there are infinitely many planes. Infinitely many planes means infinitely choice of these ABCs, right? Now, mm, how can I find equation of such plane? So equation of this plane, equation of ABC, equation of plane ABC is x by a plus y by b plus z by c is equals to 1. But this plane is continuously passing through this point. Since p lie on this plane, therefore a by sorry p by a plus q by b plus r by c is equals to 1. This is the equation of plane, right? What do we have to find? Like till here, whatever information I could have written, I have written. P was a point, ABC I have taken, so they are talking about a plane, so I have equation of plane. They are also saying that PQR lies on this, so I have one condition here, right? Now let's move ahead. They're asking about locus of center of the sphere, OABC. So let's find first of all OABC. What is OABC? Equation of sphere. You want to find out, you can, right? I'll directly use, as I said, whenever there are many questions in which equation of sphere OABC is required, so it's better that you memorize this. What was it? It was x square plus y square plus z square minus ax minus by minus cz is equals to 0, where ABC are the intercepts. All right. Now they are talking about this sphere. They are saying you have to find the locus of the center. Now, why the center is moving? Center is moving because ABC are moving. Because the complete sphere is changing. Though, so for every sphere, I have a different center. Different center. I have to find that moving. Okay. Yeah. So I have to find the locus of the center. What is the center? Center of this sphere is center of this sphere is, just give me a second. Applying that same concept, minus u minus v minus w, so what is this going to be? It is going to be a by 2, b by 2, c by 2. See, I have to find the locus of this point. That means this a by 2 eventually is going to convert into xyz at the end, right? So just, to make sure that 2 does not get involved with anywhere else in the calculation, let me take it h, k and l. Okay, I have to find locus of this. So center of the sphere is this. That means I need a relation. See, I need a relation that contains a by 2, b by 2 and c by 2. Which can be obtained here? I don't have the relation between a by 2, b by 2 and c by 2, but I do have an a, b and c. I can change them to uh, a by 2, b by 2 and c by 2. Just divide by 2. So from 1, I can write. So if I divide by 2, then I have to multiply by 2, right? So it is going to be P divided by 2 A by 2 plus Q divided by 2 B by 2 plus R divided by 2 C by 2 is equals to 1. This 2 I can take in the right hand side. So P by A by 2 means this is obviously your choice. You do not need to introduce it. But you should be clear that, we need to change A by 2 as x plus q by b by 2 plus r by c by 2 is equals to 2. Now you have a relation, and p, q, r are allowed to be in the final answer because that is given in my question. So therefore, what is the locus? Therefore, required locus is p by x plus q by y plus r by z is equals to 2. I think that was the expression as well. P by x plus q by y plus r by z is equals to 2. Okay. Break down the question. Write everything means just uh, deduce every single point that you can the from a small part of the question. Let's see this plane section of a sphere. Now we are going to deal with intersection of a sphere and a plane. So what do you imagine? What do you imagine when you imagine a sphere and a plane? Given sphere and planes are x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equals to 0. Always beta. Can we get like something else like ellipse? Maybe. Think. Can we get ellipse? And ax plus by plus cz plus d is equals to 0. Seems like, na? Chalo, let's have a discussion. So, remember, what were the two forms of equation of a straight line? One was symmetric form. Symmetric form is that means about the line, what is given, a point on the line is given, and the direction ratio of the line is given, right? There was a general form also. General form means I need to know two distinct planes passing through uh, that line, right? How do we write general equation? We write general equation by mentioning these two planes. By mentioning a1x plus b1y plus c1z plus d1 is equals to 0 and a2x plus b2. And those two planes, pi1 and pi2, I name them as 1 because they combined represent a straight line. Okay, so yes, this is a sphere, yes, this is a plane, but when I combine them, when I say equation 1, by combining them, what do they represent? That represent with a circle. You will never get ellipse. Okay, no matter whatever is your orientation of your plane with respect to the sphere, it will always be a circle. Okay? I hope that's not very difficult to see. There is will use this fact in many articles. We'll come back to this, but there is only one point that I need to discuss right now, which is here equation 1 is equation of circle in 3D. Equation 1 is equation of circle in 3D. Because see, in fact, in the line also, line is not the concept of 3 dimension. Line is a concept of 2 dimension. So when I'm representing it in 3 dimension, I can use two equations, and combining these two equations I'm getting a line in the three dimension. So similarly, equation of circle, circle is not a concept of three dimension. So in 3D I can represent it as an intersection of a sphere and a plane, right? Just this is not for this article, but you should know this also. Whatever you represent in two dimension. Now this is the point also you can refer to, 11th NCRT conic section. What is the equation of ellipse? Or let me talk about simple circle. What is the equation of circle? In that also I'll take circle whose center is origin. So it is x square plus y square is equals to 3 square, right? This is the circle. But the same thing represent circle in two dimension, but it is not representing circle in three dimension. Because what happens to the z when z is missing? What we do in three dimension, when in any equation z is missing, we assume that z can be anything. And in three dimension, look here. If this is your x-axis, this is your y-axis, this is your z, then x square plus y square is equals to 3 square. You might see that this is actually here on the xy plane. On the xy plane, center at 0, 0, and the radius is 3. Let me make it a little bigger. But you see, what is z on that plane? Z is 0, right? Because I have drawn it on xy plane. Who told us that z is equals to 0? Z can be anything. Because z can be 3 also. Z can be 1 also. So basically, this is representing a cylinder of infinite length. So this is not circle in two dimension, it is cylinder in three dimension. So if you want to represent, now the question is that, okay, then how do I represent the circle which I'm making in the xy plane in three dimension? Then better you need to mention that z is equals to 0 along with it. So here also I'm doing the same thing. This is a sphere, this is a plane. I am taking both of them together, a sphere and a plane. So obviously it is representing a circle. Now it is representing a circle. I hope that you're getting it now. Okay. Earlier, it is not an intersection of a sphere and a plane, but it is an intersection of a cylinder and a plane. But still, it is giving me a circle. It is still giving me a circle. So see, any two solids whose intersection is a circle, I can write that those two surfaces like that, and I can say that they combine to give me a equation of circle. Any questions, anyone? All right. One more concept. So let us imagine that that's your sphere and that is the plane. Okay, so we are looking at this is actually the center. Yeah? O. I hope you can imagine that O has nothing to do with the plane. O is not on the plane. Plane is below O. Okay. So what will be the intersection? Can you see the intersection is yes? Okay. Now, so from O, let us drop a perpendicular on the plane. We can do that on the circle. So let's drop a perpendicular on, or if I drop a perpendicular from here on the plane, let's say this is a line on the plane, and here I drop a perpendicular. And then from this point, let's take that to be C, I have joined it with the I have joined it to the boundary point. C point, let's say this is, okay, so this is 90 degree, right? If this is 90 degree and this is A point, so can you see that OA whole square is equals to OC square plus CA square, Pythagoras theorem? Then what is CA square? CA square is OA square minus OC square. Now, actually, this A point, this A point is beta on the sphere. So the intersection of the plane and the sphere is a circle. Every point, any point I take on that circle, that is the point on sphere also, and that is the point on plane also, because that's the intersection. So that A point, you can consider it as a point on plane also, as a point on sphere also. This time I'm using the fact that it is on the sphere. So if it is on the sphere, then what is OA? Isn't it radius of sphere? Considering the fact that I have taken a fixed sphere, fixed plane, and everything is fixed here, nothing is moving. So I have OA as fixed number. That's the radius of the sphere, right? What is OC? Because O is the center of the sphere, that is fixed, plane is fixed. So OA is also a fixed number, which is perpendicular distance from O to plane. O is center of sphere. So that means I have two fixed constants. That means this is constant. This is constant. And the whole purpose of getting this constant as was to say that okay, so if CA is constant, what is CA? What is CA? That C, A point can be changed. You see, A point has a choice. A point you can take here or here or here or here. Everywhere you get the same result. That means either I find this CA or this CA or this CA or this CA, all are same because OA is fixed, OC is fixed. So all are same. That means what it turns out. That means C, which is actually the foot of perpendicular, is nothing but center of the circle that you have obtained. I just dropped a perpendicular. I didn't say that join O, which is the center of the sphere, to center of the circle. No, I just dropped a perpendicular. That automatically comes out to be the center. We have proved it. Since it's a constant, it implies that's the definition of the circle, right? I have a constant distance from the origin, from the boundary points. So that C point is definitely the center. It implies C is center of circle obtained. Or you can write circle of intersection, like we say line of intersection. So it is circle of intersection. Yes, so we are going to use these facts in few articles. So we'll finish it right here. The basic uh, target of this article was number one, you need to see that okay, the intersection of a plane and a sphere is always a circle, and how to find the center of that circle is just drop perpendicular from the origin, from not origin, from the center of the sphere to the plane given. Okay, plane is also given. Center, I know minus u minus comma minus v comma minus w, and plane I know. So obviously I can find the foot of the perpendicular, okay, from a point to the plane. That will be the center of that sphere. Next we have intersection of two spheres. So with the intersection of two sphere, just like I said over here, that it's not like intersection of sphere and a plane is only the circle. Here intersection of a cylinder and a plane is also a circle. है ना? So this is a cylinder and then there is a plane here. Obviously you'll get a circle. So there can be many solids whose intersections can give me a circle. For example, intersection of two spheres. So let me first let me write the equation. So here I'm dealing with two spheres. So let two spheres be. First is S1, let's say, which is x square plus y square plus z square plus 2u1x plus 2v1y plus 2w1z plus d1 is equals to 0. To 0. This is the first one. And S2 is x square plus y square plus z square plus 2u2x plus 2v2y plus 2w2z plus d2 is equals to 0. Right. Let it be 2. We have two sphere. Let's say now can you see that the intersection is a circle? That intersection is this, a circle. Hmm. See, actually, the problem is when I was dealing with a sphere and a plane, then so far we are having discussion on the sphere. So eventually we'll learn many things about sphere, and we have already learned few things. For example, how to find equation of sphere if 2 points are given, two diametrical points are given, 4 points are given, and all those things. And for plane, I have enough uh, information. Equation of plane is much more simplified also, because also it is in linear form xyz, and equation of sphere is a equation in 2 degree, x square plus y square plus z square. To deal with one linear equation and one quadratic equation in 3 dimension, also in 3 variables, is easier than to deal with two equations, both in 2D. Getting my point? Right? The circle I'm referring to right now here, this one, this circle C. Circle C is is obviously the intersection of S1 and S2, but actually what I'm trying to do is I'm trying to find out that can I obtain the same circle C by an intersection of a sphere and a plane? Now where that plane will come from? Points, now points. How do we find the intersection? Intersection means there is a point which is on sphere 1 also and sphere 2 also. Every point of this circle C is on sphere 1 also and sphere 2 also. So now points lying on both spheres must satisfy S1 minus S2 is equals to 0. Okay. See this. Now we are getting somewhere, interesting part here. S1 minus S2 is equals to 0. And the statement that I have written, the converse of this statement is not true. What I have written is that if there is a point which lie on S1 also, so obviously if you will substitute here in this equation, then that will make this as 0. That is lying on S2 also. So it will make this as 0. 0 minus 0 is 0. So obviously every point which is lying on the intersection, which is nothing but the circle, is satisfying this equation. But is the converse true? Like if I take any point which is making S1 as 5, that means definitely it is not on S1. That means it is not on the sphere 1. Right? And this is S2. So there is a point, let's say 1 comma 2 comma 3, some this point, which I'm substituting here. It's not giving me 0, it's giving me 5. So definitely that is not on the sphere 1. If I'm substituting it in S2, then also it is giving me 5. That means it is not on S2 either. If it is not on S1, not on S2, definitely it is not on the circle. But it is still satisfying the equation. 5 minus 5 is 0. So my point is that yes, the statement is true, but the converse is not true. That means if you take any point which is satisfying S1 minus S2 is equals to 0, it doesn't mean that that point needs to be on the circle. It may happen that it is neither on S1 or nor on S2. Right? Am I clear here? Any questions, any doubt? So you cannot assume this as the equation of circle just because every point of circle is satisfying this. Right? It's like x by 2 plus y by 3 plus z by 4 is equals to 1. That's what? That's the equation of plane, right? Whose intercept on x-axis, y-axis and z-axis is given. There is a line on it. Every point of that line, because it is on that plane, satisfy this. But it doesn't mean that this is the equation of this line. Right? Every point of the line satisfying the equation does not mean that this equation is the equation of that line. Similarly, every point of the circle that I'm saying is satisfying this equation. It doesn't mean that this equation is the equation of that circle. It may be something that circle is contained in. This is the equation of something which contains that line 1. So beta, this is the equation of something that contains that circle. Okay, now what is that something? In three dimension, you can just simply think it through also. Let's find out. Let's find out s1 minus s2. So obviously this x square cancels, y square cancels, x square minus x square, y square minus y square, everything is cancelled, and I'm left with 2 u1 minus u2x plus 2 v1 minus v2y. What does it represent in three dimension? What does the equation looks like? Isn't it representing a plane? Which is equation of plane. That means this plane is a plane which contains the circle of intersection. So what this plane will be? This plane will be something like this. So to refer this circle now, I do not need S1 and S2. I can say that it is the intersection of S1 and the plane. S1 minus S2. Right? So therefore, intersection of, or you can write required intersection, which was the intersection of two spheres, can be represented as. So basically, I have to refer to that circle C, no matter how I write the equation. The one way of writing the equation is obviously you just mentioned two spheres. S1 is equals to 0 and S2 is equals to 0. That is your one possibility. Or you can write one sphere and another plane, means the intersection of S1 and the plane, or you can write intersection of S2 and the plane. These are our three possibilities. All three are representing the same circle, circle C. Right? Just a quick recap. To find how can I find plane containing a given line? How can I find a plane containing a given line? It actually depends upon which form of the line is given. If general form is given, that means you are already provided with two planes, one plane and the another plane. Then, okay, so if pi 1 and pi 2 is given, this is pi 1 and let it be pi 2. So if pi 1 and pi 2 is given, that means the line is given in general form. So this plane would be, so this plane would be pi 1 plus lambda times pi 2, which is actually a different plane. Right. So we, this is the required plane. Acha, what if symmetric form is given? Change your symmetric form to general form. How? Changing. No, in that case, we have to go through this. If symmetric form is given, then I know a point on the, then it is easy. Then I know a point on the plane, a point on the line, right? That point on the line is also a point on the plane because I want a plane containing that given line. So that point is on the plane also. If that point is on the plane, I know how to find equation of a plane passing through that point. Ax minus x1 plus by minus y1 plus cz minus z1. After that, how to find that capital A, capital B, capital C, because I have direction ratios of the line, which will be all perpendicular to the direction ratio of the normal of the plane. So you can find out that as well. Yeah, this revision of the concept was just for the next article. This. So basically, given was a two-dimensional object, a line, and I have extended it. I have found a plane containing that line. So how can I find the equation of yeah. So to find equation of a line whose given equation is in general form, then it is easy, right? Then I can find the plane and a random plane passing through that given point because I already have two planes passing through that point. I have to find a sphere through a given circle. But now that given circle, if that is already in the intersection of two spheres, then what it is? What is a general sphere passing through that circle? That means it will be S1 plus lambda times S2. If that given circle is the intersection of uh, two spheres, then it is fine. What if that given circle is the intersection of sphere and a plane? Then I can write it as a S plus lambda p. If this circle is the intersection of, yeah, these are the two conditions that we have done. Example we have done for the cylinder and this also, but over there also you can see if this given circle is given in the form of intersection of a cylinder and a, no, then I cannot get sphere. No. Yeah. So only these two cases. I hope we are getting clear. Hmm? It makes sense. This equation makes sense. So if it makes sense, then do this question. Find question number 4. find the radius and center of the circle x square plus y square plus z square minus 8x plus 4y plus 8z minus 45 is equals to 0. And x minus 2y plus 2z is equals to 3. Find the radius and the center of the circle. So can you see the how circle is provided? Circle is given in the form of a sphere and a plane. So it is the intersection of a sphere and a plane. So roughly speaking, what will be the diagram? That is your sphere and that is the plane of intersection, and this is the circle of intersection that we are referring to. I have to find its center, I have to find its radius. See, center we have already talked about. Just from the center of the sphere, what is the center of the sphere? See, that is 4 comma minus 2 comma minus 4. See, minus u comma minus v comma minus w. Okay, don't forget that it is plus 2ux plus 2vy. So this is the center. From center, just drop a perpendicular to the plane. So C is the center of the circle, and that point we have taken A. So OC is perpendicular to plane, or we can write CA. है ना? So by how can we find foot of the perpendicular? OC is perpendicular to CA. Let it be first. Let it be second. Let C is A comma B, no, P comma Q comma R be foot of perpendicular from O, which is 4 comma minus 2 comma minus 4 to plane 2. To plane 2. To find the foot of the perpendicular, actually it was much easier than if I find equation of that OC first, and then I can find the point. So let's find the equation of OC. For OC, I need a point on OC, which is O given, and then I need direction ratios. So direction ratios of OC is 4 minus P minus 2 minus Q and minus 4 minus R. And OC is perpendicular to CA. है ना? तो नहीं, and direction ratio of normal, and direction ratio of normal of plane. What is it? That is 1 minus 2 and 2. These are the direction ratios of the normal of the plane. So any normal will be obviously parallel to this perpendicular, because this normal is also perpendicular, OC is also perpendicular, so they are parallel. It implies 1 by 4 minus P divided by 1 is equals to minus 2 minus Q divided by minus 2, and minus 4 minus R divided by 2. Right? So these are the direction ratios, right? These are the direction ratios which are proportionate to 1 minus 2, 2. So these are the direction ratios. 1 minus 2 and 2 are the direction ratios. Therefore, equation of OC will be, a point is x minus 4, then it is 1, then y minus minus 2 divided by minus 2, and z minus minus 2 divided by 2. This is the equation. From the equation, how do we find that C point? Beta, this is a symmetric form. So any point, or let's say C is of the form, C is of the form, because C is a point on OC, is of the form k plus 4 minus 2k minus 2 and 2k minus 4. This point is on the plane also. Okay. So since C lie on plane as well, therefore, substitute in the equation of the plane. Plane is x minus 2y plus 2z. X minus 2y plus 2z is equals to 3. So k plus 4k plus 4k plus 4 plus 4 minus 8 is equals to 3. This gets cancelled. 9k is equals to 3. Yes. So k is 1 by 3. That means I got my point. I got the center. First part is done. Find the radius and the center. So at least, we have a center. Now it implies C is 1 by 3 plus 4, 12 plus 1, 13 by 3, comma, minus 2 by 3, yes, minus 8 by 3, and minus 10 by 3. You have C, that means you can find OC also, distance. Right? Now, why we are finding OC actually is to get to the next step, which is radius. See, radius is CA. CA is the radius of that circle, right? So if I know OC and if I know OA, then I can find out CA. So let's first talk about OC. I have O point, I have C point, I can find OC. Okay. So now, see, I think obviously this is one way to find OC. How can you find OC? Is you have 2 points, you apply the distance formula. There is one more way. OC is actually the perpendicular distance from a point to the given plane. How do we find that? So, find OC by we can, yes, that is one. We can find OC by applying distance formula. distance formula also. But let me show you one more way, which is finding the perpendicular distance. So OC is nothing but perpendicular distance from O to plane. Achha, what is O by the way? O is 4 minus 2 minus 4. That was the point. 4 minus 2 minus 4 to the plane x minus 2y plus 2z is equals to 3. How do we find that perpendicular distance? That is modulus of, just substitute the points, 4 minus 2 times minus 2 plus 2 times minus 4 modulus minus 3 modulus divided by square root of 1 square plus minus 2 square plus 2 square. So this is going to be 4 plus 4, 8 minus 8. So it is 3 divided by 3. So it is 1. Just one more way. So now you have OC, now you have OA, you can find CA. Now what is OA? Beta, A is on the circle. Every point of the circle is on the plane also, on the sphere also. So A is on the sphere. O is the center of the sphere. So what is OA? OA is the radius of the sphere. How to find radius? What was the formula of radius? Remember, square root of u square plus v square plus w square minus d. That was coming out to be radius. U square plus v square plus w square minus d square root. So let's find out radius. And OA, which is radius of sphere 1 is what? Square root of, but this is minus u minus v minus w, and we have to do the square. Okay, so u and minus u, one and the same thing. So it is minus, actual value of u is minus 4 plus 2 square plus 4 square. So it is u square plus v square plus w square minus d. What is d in this one? D is minus 45. So minus of minus 45. It's plus 45. Plus 45. Tell me what is it? I think it is root of 16 plus 16, 32, 32, 36, 36, 36, 81. So 9. Yeah, it's 9. And now you can apply Pythagoras to get the radius CA. Okay, tell me what is CA. Therefore, by Pythagoras theorem, so it is 5 into, just a second, 2, 2, 5. 4 root 5, yes. Yes, 4 root 5. By Pythagoras theorem, CA, which is actually radius, required radius of circle, that is going to be 4 root 5. So beta, this is your answer. Radius and center. These are the two parts of the questions. All right. Try this question. Conceptual wise, it is going to be the same. Can you progress? Okay. Question number 5. If r is the radius of the circle and circle this, prove. Okay. So, beta, O is the center of the sphere. That's the plane, right? That's the perpendicular. Perpendicular was C. You see, to find the perpendicular distance OC, actually we don't require the radius as this point center. To calculate this distance OC, basically to find that center and to find the radius is totally independent. You can find, you can find the radius first also and the center later also. They have nothing to do with each other. So they are talking about the distance. So I can independently talk about the distance part. Okay, because they are not referring to, anywhere center is not used. I have to find the radius. The radius I can find directly from here. OC is the perpendicular distance, O is the center radius of the sphere. So I can find the radius of the center as well. So from O to C, what is the perpendicular distance? This is the given sphere and this is a plane. So from center of sphere 1 is minus u comma minus v comma minus w. Perpendicular distance of perpendicular distance from O to Lx to Lx plus my plus nz is equals to 0 is what will be the perpendicular distance? Substitute the point, it will be modulus of minus Lu minus Mv minus Nw modulus divided by square root of L square plus M square plus N square. Right? So that is your OC. Alright. OA is radius of sphere. OA is radius of sphere. So that is square root of, that's the square root of u square plus v square plus w square minus d by Pythagoras theorem by Pythagoras theorem OA square is equals to OC square plus plus CA square. We have to find CA, we have to find the radius of the circle which they are taking it as R. So CA is actually small r. CA is small r. So and that's what we have to find. So what is OA? OA square, that is u square plus v square plus w square minus b is equals to what is OC? OC is this. The OC square is LU plus MV plus NW whole square minus I have taken common divided by L square plus M square plus N square plus R square. So what is R square? R square is u square plus v square plus w square minus d times l square plus m square plus n square minus minus lu plus mv plus nw whole square. Beta, that is your r square divided by. Let me multiply. Instead of dividing, let me multiply this r square also with L square plus M square plus N square. Alright. Now, can you see your right, left hand side? Left hand side, if you open the bracket, it is R square times this bracket plus D times this bracket. So, now left hand side. Let it be third. Now, left hand side is R square plus D times L square plus M square plus N square. So what is it? It is R square times L square plus M square plus N square plus D times L square plus M square plus N square. Do you have the value of L, this part? You already have it here. R square times L square M square is this. Substitute. So this is u square plus v square plus w square minus d times L square plus M square plus N square minus LU plus MV plus NW whole square, and then we have the last term, this plus D times L square plus M square plus N square. From the first term and the last term, let's take L square plus M square plus N square common. So I'll get beta U square plus V square plus W square. This is minus D here and it will be plus D, so it will get cancelled out. Cancelling out, and I'll get L square plus M square plus N square. This should remind you about something. Plus NW whole square. Yes. What is this? This is nothing but Lagrange's identity. Very good. So this is what the Lagrange's identity is between U, V, W, and U again, then L, M, N, and L again. So we follow this pattern: UM minus VL. That is UM, and that is exactly what we want. UM minus, so first you write it by your own simplification, the own pattern, and then you can simplify or give the expression like the way they want. Okay, so that's your answer. So our pattern would be UM minus LV whole square. It is a whole square, so obviously you can switch. A minus B whole square is B minus A whole square. and then plus Vn minus Wm whole square plus Wl minus Un whole square. Okay, proceed in this manner and then it will be proved. Okay, so we didn't talk about the center because nowhere it was required. R was required, so we found R directly. Next, question number 6. Prove that the plane x plus 2y minus z is equals to 4 cuts the sphere x square plus y square plus z square minus x plus z minus 2 is equals to 0. So obviously this is your circle 1, right? Prove that the plane this cuts the sphere this in a circle of radius unity. Obviously you can do that. Unity means 1, means you have to prove that radius is 1. You can do that. And you have to find the equation of sphere which has this circle for one of its great circle. So what is a great circle corresponding to the sphere? You can imagine this also, that sphere, the intersection of a sphere and a plane is definitely a circle. But what is the possible uh, greatest circle possible? You can imagine that if this plane actually passes through the center of the sphere, O point actually lie on the plane, then this would be the greatest circle. Okay, so this you have to consider it in the question. This is what they are talking about. That is the circle. So greatest circle is the intersection of a plane and a sphere if that plane is passing through that center of the sphere. In that case, you can observe that O is the center of the circle also and O is the center of the sphere also. Okay. So we'll discuss this question after a break. Sure. All right, let's start. So, there's a very small discussion we need to do for this question. You can solve it by yourself. Prove that the plane in a circle of radius with unity. So, this part you can do, right? Let's talk about the next part. So, radius is 1. Okay. Now they are saying find the equation of sphere. So, beta, see, this is the original sphere. All right. This is the original sphere. That's the plane, and you found radius of this center. This radius of this circle of intersection. That radius is 1. Right. All right. Now they are asking you to find a equation of sphere. Beta, we can find the equation of sphere if I know center and the radius of that sphere. That sphere that they are talking about is saying that this should be the greatest circle of that sphere. That means center of this circle C should coincide with the center of the sphere that we are asked. This is circle C, and they are asking a sphere whose greatest circle is circle C, right? That means center of, and this is sphere S2. S1 is given. So this is center of C is same as center of S2. So at least you get center, because see, the radius of that circle was asked, center was not asked. So center is actually they are asking in the second part, because center of C is going to be the center of this sphere. All you need to work with the radius. In fact, radius is also same. In fact, radius of that S2 and radius of C is also same. This is radius of C you have already calculated. So radius of sphere is 1. And you need to find the center of S2. You have radius of S2, you have center of S2. You can find equation of S2. All right? Sure. Now, let's do this question. Question number 7. Find the equation of the sphere which passes through circle. Pay attention on the equation of circle they have given us. Circle is cut by the plane this in a circle of radius. Find the equation of sphere, okay, which passes through the circle. All right. What is this? What is this equation? So the situation is that we have a circle and a plane, and the no. We have a circle, and the question says that the sphere passes through that circle. So it may not be the great circle like that. Circle is given. But how circle is given? Circle is not given in the form of a intersection of two sphere or a sphere and a plane. What is it? Cylinder and a plane. So it's a cylinder of infinite length. Yes. X square plus y square is equals to 4 is a cylinder of infinite length. And then we have taken the intersection with z is equals to 0. That means x axis. So this is x-axis, y-axis, and z-axis. So equation 1 comprises of two equations, equation of a cylinder and equation of this plane, whose intersection is actually, this is the plane also, z is equals to 0, z is equals to 0, and this is the equation of a cylinder, x square plus y square is equals to 4, and whose intersection is given as that circle. Okay. Acha. So how can I find equation of a sphere? Find the equation of the sphere, right? So let me just stop right here and let's see what we can do only for this part. To find the equation of a sphere which passes through the circle. How can I find equation of a sphere passes through the circle? Equation of sphere through a circle depends upon how circle is given. Equation of a plane containing a line depends upon how equation of line is given. If I already have two surfaces passing through that line, which is let's say here pi 1 and pi 2, then plane can be obtained by pi 1 plus pi 2. If circle is given in the form of the intersection of two surfaces, some S1 and S2 may not be the sphere, one can be the sphere, other can be the plane, then the sphere passing through it is given by S1 plus lambda times S2. So similarly, a circle over here is given as the intersection of two solids in three dimension. So a sphere passing through it will be given by equation of sphere. Equation of sphere through circle 1 is x square plus y square. Okay. Now see, plus not plus. Just a second. Minus 4 plus lambda z is equals to 0. But there is a problem here, and I hope by writing the equation you can observe that problem. This is not a sphere. This is not a sphere. Where is z square? That's why I haven't talked about circle as the intersection of cylinder and plane in this very article. Because yes, cylinder can be given as an intersection of cylinder and plane, but these equations cannot give me sphere. Right? Because this plus lambda of plane means equation of a cylinder plus lambda times equation of plane will not give me a equation of sphere. At least I know general equation of sphere. How does that look like? Right? So what I can do now? How can I find? Beta, circle, we very well know that circle is not just the intersection of a cylinder and a plane. It is the intersection of two sphere. It is the intersection of a sphere and a plane. It is the intersection of another sphere and a plane. So when they are talking about the circle as an intersection of cylinder and a plane, can I change that cylinder to sphere actually? Obviously, yes. Obviously, yes. Instead of taking this cylinder and a sphere and a plane, and please mind, both of them should be same circle. Both of them should be the same circle. There is one circle which is obtained by sphere and z is equals to 0. Cylinder and z is equals to 0. Can I change that cylinder to a sphere so that that sphere and z is equals to 0 also gives me the same circle, which is exactly the circle, which is exactly you can take a sphere whose greater circle is that. What that would be? Yes. Now I know how to proceed. If I have equation of a circle as an intersection of a sphere and a plane, then I can find the equation of sphere as first equation plus lambda times the next equation. So beta first equation, as you can see, I have taken a sphere which is which is a sphere whose greater circle is my obtained circle. I know how this circle looks like. This circle looks like in which the center is at 0, 0, 0. So my sphere will also have the center at 0, 0, 0. Circle. This circle has the radius 2. So my sphere will also have the radius 2. How does the equation looks like? You just need to put a z square minus 4. That was the only catch in the question. They have given the equation in terms of a cylinder in the equation of a circle as an intersection of cylinder and a plane, but I don't know how to write that, how to extract my equation of sphere from these two, so I changed this cylinder to a circle. Any doubt, anyone? All right, now, and the equation of the sphere through, okay, now I have the equation of sphere. Find the equation of sphere. So I got the equation of sphere. All I need to worry about this lambda now, for which they have given us the extra condition. And is cut by the plane this. When a sphere is cut by the plane, I know that there is a circle. I know how to find the radius of that sphere as well, right? So now let's independently draw the diagram, because then otherwise it would be, very messed up. So now this is the obtained sphere and the plane is given. How can I find radius? Forget about the fact that 3 is given right now. Okay, so from O we drop a perpendicular and like this. So this is C, this is C, this is A. So radius of that circle CA square is actually OA square minus OC square. What is OA square? OA square is the radius of the sphere. What is the radius of the sphere? Square root of U square plus V square plus W square, right? So beta U is also 0. There is no coefficient of X. There is no coefficient of Y. There is a coefficient of Z. So 2WZ. So lambda by 2 whole square. And minus D means plus 4 whole square minus what is OC? OC is the perpendicular distance from center of the sphere, which is going to be again 0 comma 0 comma minus lambda by 2. Okay, to the plane. What is plane? Plane is x plus 2y plus 2z is equals to 0. Yes. So find the distance. First substitute the point. So that is minus modulus of 0 plus 2 times 0 plus 2 times minus lambda by 2 modulus divided by square root of 1 square plus 2 square plus 2 square whole square. So what is it? And it is given to be 3. So it is given to be 3 square. So it is given to be 9. 9 is lambda square by 4 plus 4 minus 2 and 2 cancel. It is lambda square divided by 4 plus 4, 9, 3. So it is 9 minus 5 is equals to lambda square minus. I've done something wrong. This is lambda by 3. This is lambda's. Oh, okay, okay, okay. So, but square root is cancelled, no? So, where is that? Oh, this 3. Yes, yes. This is 9. Yes. That is the square. So, it cancelled. Yes. Now it's good. So, it is what? Lambda 5. 5. Lambda is 6. 5 and 5 cancel. Lambda is plus minus 6. Actually, there are two possibilities of that sphere, which passes through the circle this and is cut by the plane in the intersection. Okay, for both of them. So, beta possible answers are for lambda is equals to plus minus 6. Substitute it here in equation 3, and you'll write therefore required equation is this or this with plus 6 and minus 6. So, beta this was in 2016. Now, from now on, the article that we are doing in sphere, beta, this article is exactly same in cone, cylinder, ellipsoid, and everything. Okay, so please pay attention. After this part, actually, most of the article of the next the rest of the chapters are exactly the same. Okay, so in like the idea behind every article is exactly the same. So we are finding intersection of a line and a sphere. You can imagine the intersection of a line and a sphere, and you know how many points of intersection we can have, minimum and maximum as well. So I'll draw the diagram, but let's talk about that intuition theoretically. So first, we are provided with given equation of line. Line as x minus alpha 1 by a is equals to y minus beta 1 by b. B is equals to z minus gamma by c, and equation of sphere as x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equals to 0 is equals to 0. That is second. Now, given equation of line is this and given equation of sphere is this. Okay, how do we solve two the intersection of two objects in three dimension? We actually find a point on one of them, and then we apply the condition that what if this point is also on that sphere? That is the point of intersection, right? So how does a point looks like on the line? We know it's a symmetric form. So let's start. This all is given to us. This all is given to us. Next, now any point on line 1 is of the form ak plus alpha, bk plus beta, and ck plus gamma, right? If this point lie on the sphere, if this point lie on sphere 2, then ak plus alpha square plus bk plus beta square plus ck plus gamma square plus 2u ak plus alpha plus 2u this and 2v bk plus beta plus d is equals to 0. Okay. Now, what do we want to find? We want to find all the point of intersection. So that means any point, every point that I get on line and a sphere will be of this form. So that means I'm finding the value of k here. So the obtained equation can be written as the equation in k. And as you can observe, this will give me a quadratic in k. And obviously it will give me a quadratic in k because the intersection of a line and a sphere can give me maximum 2 points, right? This is the intersection of a sphere and a line where I am getting no point of intersection, so no values of k. So I'm getting no values of k. That means I'm getting no value, no roots of the equation, quadratic equation, which means discriminant negative. This is the situation where this line will be tangent to my sphere. That means I'll have repeated roots. Discriminant will be equals to 0, right? And then the last case where I have 2 points of intersection, right? So this is P point, this is Q point. We have the possibilities, right? I can have no point of intersection, I can have 1 point of intersection, I can have maximum 2 point of intersection. So this equation right here, this equation can be written as a square plus b square plus c square and k square plus what is the coefficient of k? It is 2. So 2 times A alpha plus B beta plus C gamma times K, and plus the constants would be alpha square plus beta square plus gamma square plus 2 U alpha plus 2 V beta Did I miss something? Yeah, I missed the coefficients of plus AU plus BV plus CW. Yeah, these are the coefficients of. Okay, and the last, the coefficients I'm writing, constants basically, plus 2W gamma plus D. That is equals to 0. Because that's your equation. That's a quadratic equation in K. That's a quadratic equation in K. Now, okay, so let me write first. The explanation is this is quadratic. So even if I do not have a picture of it, I know theoretically also that I can have maximum 2 points because this is quadratic. This is quadratic in K. Therefore, number of possible points of intersection, possible point on sphere, number of possible points of intersection of a line and sphere are 0, 1 and 2. Either no point of intersection, 1 point of intersection or 2 point of intersection. Acha. This is, acha, can you tell me what are the possibilities of a cubic equation if I solve? If I get a cubic equation in K, let's say, so what are the possible values? Means how many points of intersection we can get? What are the possible number of roots of a quadratic equation? Or what are the possible number of zeros of a quadratic polynomial? The answer, the question, seems to have a very obvious answer, but let me see what is the answer. Hmm? I'll repeat my question. If I have a if I have a cubic polynomial, then what are the number of possibilities of its zeros? For example, here for quadratic, I can have no zeros, I can have 1 0, I can have 2 zeros. But for cubic polynomial, what is the possibility? Very good, very good. That's why I asked this question. So the possibilities are 0, 1, 2, and 3. Like no roots, one root, two, no zeros, 1 0, 2 zeros, or maximum 3 zeros if it is cubic, right? Anyone with a different answer? 0, 1, 2, 3 is the possibility. Because 0 is not correct. Whenever we have a odd degree polynomial, 0 is not the possibility. That starts with 1 then. You can write it in a, ROBM box. That was basic. So if you have, you can write it in your own words. If you have a, please write the word polynomial, because when I write polynomial, it is clear that the coefficients are from rational numbers. Because if this is irrational number or real or complex, then the things will go out of the control. But polynomial means the rational coefficients. So if you have a polynomial of even degree, then you have the possibility 0, 1, 2, and so on. But if you have a polynomial of odd degree, it doesn't starts with 0. The possibility is 1. It will not have no roots. No roots is not the choice. Okay. Yeah. So, moving ahead, moving ahead, I'm finding a condition now how this line, the given line, can be tangent to my given sphere. But before that, let me see one more thing. Let us keep equation of sphere as it is. Acha, this is the next article. So let's start this next article. See, and this is the idea behind all the tangent planes. Whenever I find tangent plane of cylinder, cone, whatever, whenever they are asking cylinder tangent plane, beta, you talk about tangent line first. You talk about tangent line first, and then you talk about tangent plane. Okay, so first let's talk about tangent line. Because of the article that we have done, I know that how line can be a tangent line. How? If this equation will have repeated roots, if this equation have determinant discriminant 0, right? So beta, here I'll start by considering tangent line, but I'll do one more change here. You see, this alpha, beta, gamma point that I have taken on the line, can I take it on the sphere? Basically, I am considering alpha, beta, gamma to be one of P or Q. But is it always possible? Is it always possible? Because can I take a point on the line and on the sphere? This is only possible if I know that my line is having the intersection with the sphere, either one or two. No intersection, if it has no intersection, then I cannot assume it. Because I'm talking about a tangent line, then I know that there is a point of intersection. So this time I'll start my article with a sphere and a line where I already know that this line is um, tangent to my sphere. If this line is the tangent to my sphere, then I can have one point of intersection. And to be precise, that one point, let us take that one point to be alpha, beta, gamma only. You'll see, actually I'm trying to simplify this equation, because you see, in not over here, in the questions also, it will be very complex to deal with if I take these general conditions. So what condition I'm putting is, so I'll restart this article. I'll say that given equation of sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equals to 0. And a point on the sphere is given. And a point on sphere as alpha, beta, gamma is given. Is given. And now we are trying to find equation of a tangent through that point. This is the point of contact. So that's the this, and this is a point given. See, these 2 points are given. I have to find the equation of a tangent. So I have to find the equation of a line which passes through that alpha, beta, gamma. Initially, I don't know the direction ratios, but I can I can start at least by that point, because I know, and let A, B, C be the direction ratios. Now, any line passing through alpha, beta, gamma is x minus alpha by a is equals to y minus beta by b is equals to z minus gamma by c. If I know the values of a, b, c, then this is the equation. Okay? A, B, C. Now, also observe that you cannot take any direction ratio. Beta, that will not work because I can have many lines passing through alpha, beta, gamma, and they are not tangent. See, any other line that you make through alpha, beta, gamma is not the tangent. There is only one line passing through that alpha, beta, gamma, which is tangent, who has a unique direction ratio. So it's not like any direction ratio will work. So now you have the equation of sphere, and now you have the equation of line, which we want it to be the tangent. So what we do, we find point of intersection of 1 and 2. Basically we try to find that k value, right? So right now I'm just assuming that it's just a line which is uh, like this, है ना? Right now it is not representing the tangent. Right now it is representing this, any random line. So what is the point of intersection of this line and the sphere? Any, sorry, point of intersection. Point of intersection of 1 and 2 is given as, is given by, let's write down the equation, but note, beta, this is the equation I'm writing, है ना, because it's the same. This is what I'll obtain. But can you see that there is an edge here? The constant becomes 0, beta. But alpha comma alpha beta gamma lie on a sphere, so it will satisfy the equation of sphere. What does that mean? Lie on sphere, it implies, what is the equation of sphere? Alpha square, equation of sphere, substituting alpha beta gamma, alpha square plus beta square plus gamma square plus 2u alpha plus 2v beta plus 2w gamma plus d is equals to 0, which means this equation is reduced to, it implies, therefore equation 3 reduces to a square plus b square plus c square times k square plus 2a alpha plus b beta plus c gamma plus au plus bv plus cw. CWK is equals to 0. So far, I have not applied any condition which says that line 2 is actually the tangent line to line 1, to sphere 1. No condition. I have just taken a line passing through alpha, beta, gamma, and I'm trying to find the point of intersection. But if I want this line to be the tangent, then I should not have 2 points of intersection. I should have only 1 point of intersection, right? So now your quadratic also is reduced to something good, right? So k common, and I'll have please note that I have started with a situation where my line was passing through a line which is already on the sphere. So at least one point of intersection I have. There is no such case of no solution here. Right? So the intersection of this line and the sphere will at least have one point of intersection and maximum two, in general two. So I solved it and I actually got two values of k that will give me two different points on the plane. Now I'll impose the condition. Now my condition is that if this line, if I want my line 2 to be the tangent line, then I should have only one point of intersection. So these two values of k is actually only one. Actually they are same, the roots will be same. if line 2 if line 2 is tangent to sphere 1, then a alpha, then you can write, then let me take it equation number 4, then equation 4 must have repeated roots, must have repeated roots. Also it implies these two are same, beta the fraction has to be equals to 0. Fraction is 0 if numerator is 0. It implies a alpha plus b beta plus c gamma plus au plus bv plus cw is equals to 0. This is a condition on the line, on this line. This is the condition on this line. If this line is the tangent to the given sphere at the point of contact alpha, beta, gamma. All right. So just one more simplification. We'll talk about tangent plane tomorrow. Please go through this tangent line part. Alpha plus u plus b times beta plus v plus c times gamma plus w is equals to 0. Let it be 5. So you can write it as a note. So what do we get here? We get a condition. Line 2 is tangent to sphere 1 if condition 5 is satisfied. We'll use this to get to the equation of tangent plane now in the next class. Okay, that's it for today. Thank you so much, everyone. Thank you. Thank you so much. Beta D was removed. I hope D means you are referring to this, how this is removed, right? The constant part. Yeah. So it is removed because the earlier this alpha beta gamma was on the line. I don't know whether it is on the sphere or not. Right. But this time actually I have started with a point on the sphere and then I tried to find a line through it. So definitely this point is the point of intersection of line and the sphere. So alpha beta gamma is lying on the sphere. And if alpha beta gamma is lying on the sphere, then you can see that it is alpha square plus beta square plus gamma square plus 2u alpha plus 2b beta, means that it should be equals to 0. And this is exactly this. This is equals to 0 because it lies on sphere. All right. Okay.